Hi guys, it's Miss Catalano here. I hope you guys are doing well and enjoying this time with your families and getting your work done. Today I will be teaching you how to add terms with exponents. Now, if you took a look at the PowerPoint, you kind of understand what I'm talking about. This is just for extra guidance. So, in order to add exponents, here are the rules. You must have the same endings. What do I mean by the same endings? Well, here's an example. I have x to the 4x squared plus 3x squared. Would I be able to add those together? Yes. Why? Because they have the same ending of x squared. Here's another example. I have 2x to the fourth and 9x to the fourth. Would I be able to add those together? The answer is yes, because I have the same ending of x to the fourth. Here's the last example. 7x to the fifth and 19x to the seventh. Would I be able to add those together? The answer is no, because they have different endings. X to the fifth is not the same as x to the seventh. Therefore, you would not be able to add those together, and I will show you what to do in that case if you end up getting a number like that. But first, I want to show you how to add exponents with like terms. I promise that's an L. Here is how you do it, regularly. What do I mean by regularly? You'll see in a bit. So my first problem is 4x squared plus 3x squared. Now, my answer is going to be something x squared because you keep that ending. 4x squared plus 3x squared is something x squared. How do I figure out what that something is? I just add the 4 together with the 3 to get 7x squared. 4x squared plus 3x squared is 7x squared. Another example, I have 2x to the fourth and 9x to the fourth gives me 11x to the fourth. You keep the same ending of x to the fourth and you add the coefficients. 2 and 9 gives me 11, so 2x to the fourth plus 9x to the fourth gives me 11x to the fourth. Last example is 7x to the fifth and 19x to the fifth. They have the same ending of x to the fifth, so my answer is going to be something x to the fifth. 7 plus 19 gives me 26, therefore 7x to the fifth plus 19x to the fifth gives me 26x to the fifth. Always leave the endings alone. When you're adding, the only thing you're adding is the coefficients. Do not add the exponents. That is wrong. Leave it alone. X to the fifth plus x to the fifth gives me something x to the fifth. Here's an example of how to add exponents with unlike terms. You just don't. So here's an example. 7x to the fifth and 19x to the seventh. X to the fifth is not the same as x to the seventh, so I just can't add 19 and 7 together. What I would do is leave it alone. My answer would be 7x to the fifth plus 19x to the seventh. You can't simplify that further. Another example, 12x to the fourth and 7x to the third. You can't add those together. So you leave it as 12x to the fourth plus 7x to the third. You can't add them together because x to the fourth is not the same as x to the third. You could add these together because x to the fifth is the same as x to the fifth. And I also want to mention that anything that's just x, like 2x, can also be written as 2x to the first. All right, now I'm going to teach you how to subtract exponents. So subtracting exponents is kind of the same gist. The rules are you must have the same endings. What I mean by that is exactly what I meant by the addition. So 23x to the fourth minus 18x to the fourth, we can subtract these because they have the same ending of x to the fourth. Another example, 18x to the third and 4x to the third can be subtracted because they have the same ending of x to the third. One last example is x to the 7th minus 2x to the 9th. I cannot subtract those together because they have different endings. X to the 7th is not the same as x to the 9th, so you cannot combine your terms. All right, so here is how to subtract exponents with like terms, exactly like we added them regularly. This time we are just subtracting. So 23x to the 4th minus 18x to the 4th have the same ending of x to the 4th, so my answer is going to be something times x to the 4th. Well, what's 23 minus 18? 5. So 23x to the 4th minus 18x to the 4th gives me 5x to the 4th. Let's keep going. Now I have 18x to the 3rd minus 4x to the 3rd. Well, they both have the same ending of x to the 3rd, so my answer is going to be something times x to the 3rd. Well, what's 18 minus 4? Subtract your coefficients. 14. So 18x to the 3rd minus 4x to the 3rd gives me 14x to the 3rd. All right, last example for this. I have x to the 7th, 11x to the 7th minus 2x to the 7th. Same thing, they have the same ending of x to the 7th, so my answer is going to be something x to the 7th. Well, do the subtraction of the coefficients. What's 11 minus 2? 9. So 11x to the 7th minus 2x to the 7th gives me 9x to the 7th. Always leave the endings alone. Do not subtract x to the 7th minus x to the 7th. Just leave it. Now how to subtract exponents with unlike terms. Again, same as in addition, you don't. So here are two examples. 11x to the 7th minus 2x to the 9th. We can't subtract because x to the 7th and x to the 9th are not the same. So we just leave it as 11x to the 7th minus 2x to the 9th. That would be my final answer. Same thing with 12x to the 4th minus 7x to the 3rd. X to the 4th is different than x to the 3rd, so we cannot do the subtraction. You would just leave your answer as 12x to the 4th minus 7x to the 3rd. You cannot simplify that further. This is a 1, I promise you. All right, guys, you know the drill. If you have any questions, email me or Mr. Park. You have a Google Forms activity that is due at 11:59 tonight, so make sure you get that done, and I will hear from you all later. Bye.